To you, this obviously looks like the number 7, but to a computer, it's just a matrix of numbers. No shape, no meaning, and no idea what it's looking at. So how do we turn this raw pixel data into real, actual recognition? The problem is you can't really just write rules for this. You can't just program if it has a horizontal line and a diagonal stroke, then it's a number 7. Well, why, you may ask? Because handwriting is inconsistent. Everyone writes differently. Some people curve the numbers, some slash them, and some barely even make them readable. So instead of hard coding these rules, we need a system that can directly learn patterns from data. And that's where machine learning comes in. Machine learning flips traditional programming. Instead of giving the computer rules, we give it examples, and it figures out the patterns itself. And that's exactly the idea I wanted to thoroughly understand. We all use AI constantly, but most of the time, we're just users. I didn't just want to use a machine learning model, I wanted to actually build one and see how it learns. So I started with something simple but foundational: handwritten digit classification using the MNIST dataset. MNIST contains 70,000 labeled images of digits from 0 to 9. Each image is 28 by 28 pixels. That means that every digit becomes a vector of 784 numerical values representing pixel intensities. To us, it's clearly a number, but to a computer, it's just high-dimensional input data. So I built a neural network to map those 784 inputs into 10 classes, one for each digit. But building the architecture is only half the process. A neural network doesn't know anything until it's actually trained. So after defining the layers, the activation functions, and the optimizer, I trained the model on the MNIST dataset. During training, the network processes thousands of labeled images. For each image, it makes a prediction, then compares it to its correct label using the loss function, then updates its internal weights using backpropagation and gradient descent. This process runs for multiple epochs, which means the model sees the dataset several times. What's happening mathematically is optimization. The network is adjusting its parameters to minimize prediction error across high-dimensional input data. Once training was completed, I evaluated the model on unseen data to measure its performance. And that's when it got interesting, because now, instead of guessing, the model had learned statistical patterns from the dataset. Patterns like curves, stroke density, and spatial structure. That allowed it to generalize to new handwritten digits. But I didn't just want this to be a percentage of accuracy in a notebook, so I built a graphical user interface. With the newly built GUI, I can draw digits manually. The drawing is converted into a 28 by 28 grayscale image, normalized, then reshaped into the required input vector. Then it's passed through the chain network. The model outputs a probability distribution over digits 0 through 9 and selects the class with the highest confidence. Seeing it classify something I just drew in real time made the pipeline feel complete. From raw pixel data into structured prediction, not because it was programmed with rules, but because it was trained to learn patterns. And that's when it clicked for me. It's not seeing numbers, and it's definitely not understanding handwriting the way we do. It's performing pattern recognition. It's optimizing its parameters to minimize a loss function. It's extracting structure from raw numerical data. And if it can learn to classify handwritten digits from pixel intensities, the same principles can scale. The exact same foundations, supervised learning, optimization, neural networks, are used in facial recognition, medical image diagnostics, and autonomous vehicles. MNIST might look small, but conceptually, it's a simplified version of how modern AI systems learn from data. This project wasn't about digits, and to be honest, it was never really about digits. It was about understanding what it actually means for a machine to learn. And building this project from scratch really changed the way I see AI. Because now when I hear the term machine learning, I don't think magic. I think optimization, I think gradients, I think matrices. And that shift in mindset from using AI to understanding AI is exactly what this project gave me. Thanks for watching.